Hello students. So today we will see few concepts. What do you mean by accuracy, precision, error and significant figures. Now we will take an example. Suppose there is a rod of length, you can say 8.5 centimeters. So there is a rod of length 8.5 centimeters is there. Now in lab they have asked a student to measure the length of this rod by giving two different devices, or you may say two different scales. So device A and device B. So two different scales, you may say, they have given and asked him to measure the length of this rod. Now you may think you are only measuring the length of that rod using a tape or a scale. So when you are using A, for example, you may get its value as 8.4 centimeters, you may say. You are getting it as 8.4 centimeters. Using device B, you are measuring its length and you are getting it as around 8.35 centimeters. 8.35 centimeters. Now here, if you observe the readings which you have obtained by both scales, out of these two, which one is more near to the actual value, or you may say this as a true value. So if you observe these two, 8.4 is very near to this compared to this. So we say that this is more accurate. More accurate. So the nearness of measured value with the true value is called accuracy. The nearness or closeness, you may say, closeness of measured value with actual value or true value, that closeness we call it as accuracy. Clear, students? So accuracy is closeness to the real value or true value. Now if you observe these two scales, from first scale, that is A, you are getting digit only up to 1 decimal point. So after a point you are getting only 1 decimal place. Using this scale B, you are getting up to 2 decimal places. So its limit of resolution, or you may say precision, is more. It is more precise than this. This is accurate, it is near. But number of divisions more you are getting in second one. So this we say it is more precise or precision. So precision means the limit of resolution is more, or number of decimal places you are getting is more. So limit of resolution is more, or in simple words you may say number of decimal places you are getting is more. Decimal places is more. So those values we call it as more precise. So accuracy is nearness to the true value. Precision means the more number of decimal places you get, it's more precision or more precise we say. Now the difference between a true value and measured value is called error. So error is difference between true value and measured value. So it is difference between true value and measured value. So if you take first one, 8.5 minus 8.4. 8.5 minus 8.4. So error is of about 0.1. Similarly, if you subtract this, you will have 0.15 error is there. In error, there are different types of errors, systematic error, random error, etc., which we will be seeing in our next session. Now, to denote a value of measured quantity, there are certain rules up to what decimal place, how many digits you are required to write, and that we call it as a significant figure. That we call it as a significant figure. So, we will see with an example what it means. So, first, accuracy means nearness or closeness to the measured true value, Precision means limit of resolution is more or you are having more number of decimal places. Error means difference between a true value and measured value. Now, to understand significant figures, I will take an example. We will take the scale with which you are measuring. So, scale which you regularly use in your school days, or now you will be using in college days. So, if I take scale, just I will take reading on scale. So, here I am having 5 centimeters, you may say 5 centimeter. So, then 1, 2, 3, 4, 5, 6, 7, 8, 9, this is 6 centimeter. This is 6 centimeters. Now, you have measured a length, or say you have measured a rod. So, rod is from here to here, I will say. So, rod is from here to here. So, now you are measuring this value. So, if you measure here, it will have somewhere over here you are getting it. You are getting over here. Now, two students, yourself and your friend, are measuring. So, I will take yourself as A, boy A, and another one I will take it as boy B. Both of them are measuring. Now, here, boy A may see it and say its value as 5.5, 0.6, it is here. So, 5.67 he may say. Sir, its reading is 5.67 centimeters he may say. Another boy B, he will measure it and he may say it as, sir, no sir, it is 5.68 centimeters he may say. 5.68 centimeters. Another may measure it and say it as, no sir, it is 5.66 centimeters he may say. So, now among these two values, if you observe, the first two digits we are very confident about, because we are having reading over here 1, 2, 3, 4, 5, this is 6. So, up to this we are confident. So, first two digits we are confident about this. First two digits we are confident. So, next digit we are not confident or uncertain. So, this digit which we are taking is uncertain. So, both together we are writing its value. So, that significant figure means it is a number, or you may say all the digits. Number of digits we are certain or confident. Significant figure is number of digits we are certain or confident. We are certain plus next digit which we are uncertain plus first uncertain digit, you may say. So, first uncertain digit. So this we call it as a significant figure. Clear students? It is number of digits we are certain or we are confident. So first two digits we are confident plus first uncertain digit. First uncertain, that is 8. Some may say it is 5.6824 sir. So they are not confident about further digits because here marking is not there. So that together we call it as significant figures. Now if you take this number, confident digits how many are there? 2, 5 and 6. First uncertain digit is 8. So total number of digits we are having is 3. So 3 is a significant figure of this quantity or measurement, you may say. 3 is the significant figure. Clear students? There are some rules for writing significant figures. I will explain those with examples. So definition of significant figure is clear. It is a number of digits we are certain plus first uncertain digits. So there are around 6 rules which we are required to know. So we will see the rules. First one, if there is a non-zero number, then all digits are significant. So first rule what it says, all non-zero digits are significant. All non-zero digits are significant. Now for example, if I take 2758 is a number. Now if you observe, there is no zero over here. So all these digits you should count. So significant figure is how much? 4. Suppose if it is in the form 3.14. So if you observe, there is no zero here, all are non-zero. So you are required to count all these. So number of significant figures will be 3. So significant figure is equal to 3. Clear students? This is first rule. Second, if there is 0 in between non-zero, we even count that number also. So 0 appearing in between. So if there is 0 in between two non-zero numbers, then we count that also. Now for example, if number is in this form 27058. Now if you observe here, you are having 0 in between these non-zeros. So you are required to count this 0 also. So here total number of digits will be 1, 2, 3, 4, 5. So significant figure is 5. Significant figure is 5. Now suppose if it is in this form 2070508. So even if you observe here 0 is in between non-zeros, so you are required to count all the numbers. So significant figures will be 1, 2, 3, 4, 5, 6, 7. Similarly here if I take 3.1042, so again 0 is in between, so you are required to count this. So 1, 2, 3, 4, 5, so significant figure is 5. This is the second rule. Clear students? First, all non-zero digits you are required to count. Second, if 0 comes in between non-zero, you are required to count that digit also. Now third, if I take third one, so if there is a number with no decimal point, so there is a number with no decimal point, then all these zeros at the end are not significant. So all zeros at the end. There is no decimal point, zeros at the end. Zeros at the end. These zeros at the end are not significant. Are not significant. If there is a number with no decimal point, so I will take this one. 2758000 if it is there. So third rule, what it says that if there are zeros at the end in a number having no decimal points, then these zeros are not significant, means you are not required to count these zeros. So just number of significant figures means this you will have. So significant figure is equal to 4. Clear, students? Now suppose if it is in this form, 207580. 207580. What it says, zeros at the end you should leave. But if there is a zero in between, you are required to count by second rule. So here up to this you are required to count. So number of significant figures here will be 1, 2, 3, 4, 5. So significant figure is equal to 5. Significant figure is equal to 5. Clear, students? So first, all non-zero digits you should count. Second, if zero comes in between, you are required to count. Third, in a non-decimal point number, means there is no decimal point, all the zeros at the end are not significant. Clear? Then we will go for the next rule. Next we will see fourth one. Fourth one we will see. So if there is a number less than 0, you may say. So no, sorry, less than 1, fourth one. If number is less than 1, then zeros to the right of decimal point, are not significant. To the right of decimal point are not significant. Zeros to the right of decimal point are not significant. So now for example, less than 1 means you will be having in this form 0.00375 number is there. So zeros to the right of decimal point and to the left of non-zero digit, means these zeros are not significant. Means you are required to count just these 3. So here you will have significant figure is equal to 3. Significant figure is equal to 3. Clear, students? Similarly, if I take 0.0005053. Now again you are required to leave these 3 zeros. These 3 zeros are not significant. You are required to count these numbers. So 1, 2, 3, 4. So here you will have significant figure is equal to 4. This is our fourth rule. So if we take fifth. Now if a number has a decimal point, so number has a decimal point, then zeros at the end are significant. Zeros at the end are significant. Now similarly, if I take this example, so 0.0037500. Now if you observe here, So these zeros are not significant. These are not significant. These are not significant. But zeros which are at the end, these zeros are significant. Means you are required to count these zeros. So if you now count 1, 2, 3, 4, 5, 6. So significant figure is how much? 6. Significant figure is 6. Now similarly, for example, 0.050500 if I take. So after decimal point, which 0 will be there? This is not significant, while all these are significant. So you will have 1, 2, 3, 4, 5. So significant figure is equal to 5 units. Clear, students? Now finally, sixth one. Now for example, if I take a number, for example, if I take 4.700, 4.700. If I take a number, if I take 4.700 meters is there. 4.700. Now, whatever unit you express, the number of significant figures remains the same. It does not change. It does not change. Now, suppose I want to convert this into centimeters. Means centimeter I want to convert. So 100 centimeter is equal to 1 meter. So I should multiply by 100. So if I multiply by 100, I will get this as 470.0. I will get it in centimeters multiplied by 100. So if I multiply by 100, I will get it as 470.0. Now if I want to convert it into millimeters, if I want to convert it into millimeters, I have to multiply by 1000. So if I multiply by 1000, I will get 4700 millimeters. 4700 millimeters. Now, if you observe, now here you may get confused. If you take this first term, here number of significant figures will be 1, 2, 3, 4. Because zeros at the end we are counting in a number with a decimal point. So 4 you will have. So here also you will have 4 as a significant figure. But here if you observe, there is no decimal point. So if there is no decimal point, the zeros at the end we neglect or we leave. So significant figure will be 2. So in such cases where you get confused, what rule states that you should express this as a power of 10. You should express the number as a power of 10. Now, this is given number meters. Now, instead of writing this in this form, you should write it as 4.700 into 100. 100 means 10 raised to 2 centimeters. 10 raised to 2 centimeters. Similarly, 4.700 into 10 raised to 3 millimeters. So, a number is expressed in the power of 10. Then, this is irrelevant. Power of 10 we don't consider. So, just you are required to consider this. So, if you now observe, so number of significant figure is same in all 3. So, sixth rule states that you should express it in power of 10. So, express as power of 10. Power of 10. So, where that power of 10 we are not considering, or it is irrelevant in determining the significant figure. Clear, students? So, fourth rule, if number is less than 1 means 0.0. So, zeros to the right of decimal left of non-zero digit are irrelevant, means you are not required to count these. So significant figure will be 3. If there is a decimal point in a number, then zeros at the end are taken into consideration. You may see here or here. Sixth, if it is in the written in the terms of power raised to, we call it as order. So this we are not considering. And compulsory decimal point should be given after 1 digit. After 1 digit, you are required to compulsory write decimal point. Clear, students? So you can go through these definitions and rules once again, and in next session we will see errors and different types of errors.